Hello Gators, this is 6-4, proving a quad is a parallelogram. I can use the sides, angles, and diagonals of a quad to determine whether it is a parallelogram. Let's take a look at this question. Can you explain why you cannot conclude that ABCD is a parallelogram? Now remember, the idea of a parallelogram is we must have parallel lines. In this figure, we can get the two triangles congruent. And once the triangles are congruent, we can get these corresponding parts congruent. But these two angles congruent doesn't make lines parallel. In order to make lines parallel, you can have corresponding angles congruent. You can have alternate interior angles congruent to make lines that are parallel, but not adjacent angles. Adjacent won't work. So this is why we cannot conclude this is a parallelogram. By the way, we can conclude this is a kite. Let's take a look at a theorem that will help us understand when something's a parallelogram. In this theorem, it says if both pairs of opposite sides of a quad are congruent, then the quad is a parallelogram. So here's, if you see both opposite sides congruent, you're going to be able to say it's a parallelogram. Let's see why. If I draw the diagonal, I am going to be able to prove the two triangles are congruent by side, side, side. Once the triangles are congruent, I can get angle 1 congruent to angle 2. Remember that angle 1 is from angle C, and it goes with angle A in the other triangle. Angle 3 and angle 4 will also be congruent. Same reason. Angle 3 is this, angle A, and it goes with C in the other triangle. And these will be congruent by C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Now, why is this important? Well, having angle 1 and angle 2 congruent, we have alternate interior angles. So therefore, we can say BC is parallel to AD. Let me change colors. And when we have angle 3 congruent to angle 4, we're going to be able to say that AB is congruent to CD. And this is because if alternate interior angles are congruent, then the two lines are parallel. Now we got parallel here and we got parallel here. We definitely have a parallelogram. Let's take a look at this. Do we have a parallelogram? So let's take a look at 153 and 27. Notice that 153 and 27, these two do add up to 180 degrees. So we'll be able to say that DE and FG are a parallel because if same side interior angles are supplementary, then the two lines are parallel. Let me change color. Now we can say EF, this one, and this one are parallel. I want you to notice that these two angles add up to 180 degrees. So if same side interior angles are supplementary, then the two lines are parallel. If you can convince me that we have two sets of parallel lines, it has to be a parallelogram. So now this is going to be a theorem. If an angle of a quad is supplementary to both of its consecutive angles, then the quad is a parallelogram. So if these two right here add up to 180, and if angle A and angle G add up to 180, we are going to get parallel lines. Now, there's another very interesting thing. Not only do we get these parallel lines here once these are supplementary, I want you to notice that these two angles add up to 180, and these two angles add up to 180. And if you subtract angle A from both sides, you're going to get angle B and angle D. What I want you to notice is that in this situation, B and D are going to be equal, and so will A and C, which leads to our next theorem that says if both pairs of opposite angles of a quad are congruent, then the quad is a parallelogram. So if you see this picture, if you see opposite angles congruent like this, then you're going to be able to say it's a parallelogram, because that's going to ensure that we have parallel lines. Let's look to see if we have enough information to prove that that this quad is a parallelogram. And for the first one, I'm going to say yes. And here's my reason. If both, don't forget the word both, if both pairs of opposite angles are congruent, then it's a parallelogram. Over here we have opposite sides congruent, so the answer is yes. And here's our theorem. If both don't forget the word both, if both pairs of opposite sides are congruent, then it's a parallelogram. And we can abbreviate parallelogram with that symbol. Here, the answer is no. We have one pair of opposite sides, but not the other, so we can't guarantee that. Over here, the answer is yes. I can see we have both pairs of opposite sides congruent, then it's a parallelogram. All right, for what values of R and S will W, X, Y, Z be a parallelogram? So we want to force this to be a parallelogram, so we need to force both pairs of opposite sides to be congruent. So let me force these two sides to be congruent. That would be S plus 5 has to equal 2S minus 2. Subtract S on both sides, and now add 2 to both sides. And so S would have to be 7 for that to happen, because S being 7, that would be a 12. S being 7, that would be 14, take away 2, which is 12. This would force these two to be the same. Okay, for R, we would have to make opposite sides, again, equal to each other. Let's go ahead and solve. I'm going to subtract 4R on both sides, and I'm going to subtract 1 on both sides, and then R is equal to 2. If I put a 2 in here, that'll be 15. If I put a 2 here, that'll be 8 and 7, and that'll be a 15. So I have forced opposite sides to be congruent when I allow S to be 7 and R to be 2. Let's take a look at this problem. How can we force this to be a parallelogram? Well, we want to force both pairs of opposite angles to be congruent. Then it'll be a parallelogram. So we want to force angle S and angle U to be congruent. So I'm going to write 5A equals 3A plus 14. Subtract 3A on both sides. 2A is equal to 14. A is equal to 7. If A is equal to 7, this will be a 35-degree angle. If this is going to be a 21 and 14 will be 35. I have forced these angles to be congruent. Now I'm going to force the other angles to be congruent by making them equal to each other and solving for B. I'm going to subtract 3B on both sides, and then I'm going to subtract 1 on both sides. Okay, 3 times 36 is, let me calculate that, 36 times 3 plus 37. That answer is 145. And if I take 36 times 4 and then add 1 to it, I also have 145. And I want you to notice that these are supplementary. And these are supplementary. That's what parallelograms should look like. And here is our summary so far. What we've discovered is a quad is a parallelogram if two pairs of opposite sides are congruent. A quad is a parallelogram if one angle is supplementary to both consecutive angles. And a quad is a parallelogram if two pairs of opposite angles are congruent.